slides, a couple of pictures to show you. Um, so the low voltage guys, we have first floor, second floor for the project that we're working on. First floor, second floor, we need to design a complete low voltage system for it. And our low voltage, like we talked about yesterday, guys, include a TV system, a phone system, and a signaling system, aka security system. So these are the systems that this chapter covers, and these are the systems that you guys are required to install in your building. So do me a single very important favor, read these chapters. It really gives you a better understanding of how the systems are put together. Cool? Everybody's okay with this? And then next chapter is going to talk about the fire alarm and heat detection. Okay. A few things that we're going to talk about, again, back into residential. Installation of telephone and TV wiring into a residential, the rules and regulations for installing wiring methods for TV, television, as well as telephone, as well as Cat 5, I guess, for dwellings, including that will be including an antenna or Cat TV, cables or a dish, and a couple of rules and regulations you have to do. I can tell you very simple regulations for all the low voltage systems. If anybody ever asks you guys, can you install a low voltage wiring system with a high voltage wiring system? The answer would be what? No. They can't be in the same cable or in the same conduit. Same cable sometimes unless they're listed for, the same cable or the same conduit. The general rule is you can't, or box. Okay? So these are the rules and requirements. We'll talk about this one. Basic operation of a satellite, that dish, satellite antenna, so-called the dish. How does it work? Just understanding. And how do you bring the signal directly into your house? Low voltage wiring system for a chime. Remember yesterday, Matt, what did we do? We threw a chime with a couple of push buttons in the front and the back of every apartment. So we'll talk a little bit about the wiring methods for this. Any comments, guys? Any questions about these? So these are what this chapter is supposed to cover. So a couple of things, guys, television and closed cable TV and so forth, highly technical stuff. In the state of Minnesota, we have two licenses. We have a license as journeyman, and that leads into a master. A journeyman can do all this wiring, and we also have a specialized license that's called power limited technician, where we can assign it to the people who do the low voltage. And then they become more, we give them more training, math, they go to advanced training, because I don't know if you guys realize things are getting very complicated in the field of television and internet and phone, and everything is meshed together. I have a smart TV at my house. I can use it as a laptop. I don't know if anybody have used it. You can use it as a laptop. My TV, I can use it as a TV. I can Skype through it, so use it as a phone. So things are getting meshed together, so more complicated. Highly technical field, so it needs more competent people to work on it. Just because we're a journeyman electrician that you have not installed a closed circuit TV, you might not be able to do it, even though your license allows you to do it. So be aware of that one. Should be installed by competent television, installed by competent television people or technician. So all these, just be aware of that one when you install it, especially when it comes to commercial industrial. It becomes really most of the electrical contractors, guys, and engineering firms, they have a division that specializes in low voltage. The reason why they have a division, because there's so much knowledge to be gained in this field that one individual cannot, shall not, will not have a deep understanding of the power distribution system, lighting system, receptacle and power layout system, CAD, Revit, and all the low voltage system. It's just impossible. So these standardized with low voltage systems. Just be aware of that. Shielded coaxial cable is the wiring method for television. You guys understand it. And for remodeling, the same thing for remodeling. If you do remodeling, typically they fish the shielded coaxial cable. So if you are to run a television, the wiring method of choice is going to be a coaxial cable. For our project, here's what you're going to be doing. This is directly related to our project. What you're going to be doing for our project, guys, is you need to have something called a signal splitter, like this one, a splitter. You have an input. You have, these are coaxial coaxial cable. This is my in. These are my outs, and from here you can go to a TV jack from each and every one of these. So for the apartment building that we have, guys, that's what I would like you to install. Yesterday when we were doing the layout, I told you we're going to put TVs in certain location, bedrooms and living rooms, right? These will be cabled as home runs directly into so-called cable splitter. The job of this splitter, guys, is take the signal that's coming from the antenna here, or a signal that's coming from the satellite dish, or a signal that's coming from cable TV, your cable TV provider, split the signal into three and send the signal to three jacks, TV jacks. Can I have thumbs up, Chad? We fully understand that one. I want you guys to show this one on the plan, and you're going to call this is yesterday we call it data slash phone panel or splitter. So we're going to have something like data phone splitter, something like this one on the plans to indicate the location of this. I'm sorry, the location of this TV splitter. TV splitter. Okay. Any comments, guys, about this one? You bring your coaxial cable in, 3 out. Now, you can bring 2 ends, 4 out or 8 out, so they have different combination that they do of these guys. So if you have, you can bring a cable from your satellite dish and a cable from your antenna, and you to a mixer here, and sometimes they have power, 120 power coming to it, 120 volt power coming to this mixer. That power atom will boost the signal. That will boost the signal. Okay, any comments, any question about this splitter for the TV? So I want to remind you guys, we have 4 apartments, right? Each apartment is going to have one of these, as well as the main coming to the building. You're going to have also a main coming to the building, and we're going to assume that this is my main and 4 coming to each one of these apartment cable TV. So it's going to look like something like this, and each one of these. So here's my main for the apartment. This is for apartment -1 and 2 and 3 and 4. So we're going to assume a cable TV, coaxial cable is going to come to the apartment building. There's a splitter in the basement. That's what you guys are going to be doing in your apartment. Split it into 4, go to every apartment. From every apartment, we're going to split it again into 4 and go to these 4 locations that we need TV in this apartment. Can I have thumbs up, Chad, how we're going to do that? You will be required, not this week, next week, to draw this one for me. Very simple. You put a splitter at the top here, split it 4 times, go again to another splitter, split it 4 times. So that's what you're going to be doing for the TV. Any comments, any questions for TV? You're going to use something very similar to this one. TVs, guys, in order for your TV and my TV to work, they need 2 things. Number 1, you need the power outlets. That's why yesterday we were installing the TV jacks or outlets right next to a power outlet, right? Why do you think you're going to plug your TV and get the signal? And also you need the signal source. You need the signal source, you get it typically from the coaxial cable that will be tied at the other end with an antenna or cable TV service or satellite dish, right? 3 sources will give you this signal. Coaxial cable, the shielded coaxial cable, shielded to protect the signal. Coaxial cable is called 75 ohm RJ6 coaxial cable. That's the most commonly used. What they do is they have this highway of information, that copper core, and the signal goes right through it. Around it, guys, will be shield. And the reason why they have that shield, so the signal goes through the core, and the shield is to protect the signal from corruption and interruption and noises from other signals, right? So everybody understand what the job of the coaxial cable? Here's the signal goes right through it, and around it you shield around that cable. So why do you think we shield around that cable, right? You've seen it. Everybody saw it. We've seen a coaxial cable, right? Everybody have seen a coaxial cable, I assume. So we shield around it to protect the signal as it goes right through that core to protect it from interference. right? Because when you're watching your favorite sport, you don't want interference coming into it. So that's the most common common wiring method for the television. So central connection point is used for let-in cables. You can, the end at the other end, so this is where you can tie to your splitter from this side. From this side, you have one option. You can go to an antenna, like we said, or you can go to a satellite dish, or you can go to a service, a cable TV service from the other end. Does that make sense, guys? Not all of them together, one at a time. If you want to bring them all together, you bring them to a splitter. 3 input splitters, split them, and you can get your cable TV, antenna, and dish. But you have to bring them to a mixer, and from the mixer, from the splitter, you bring them to a mixer, and from the mixer, you take them inside your house. If you have a satellite dish, you need something called satellite dish receiver. So when you bring these signals in, as you come out of the splitter, you need to land it into a receiver. What the receiver, guys, it takes the signal and recognize it, right? Receive the signal, and then send it back into the outlets. That's how you get your satellite dishes. You need to have your receiver. It's not enough to receive the signal. You can get the signal, but in order to get the signal, use the signal, you need the receiver. Receiver will be tuned to receive the signal and utilize it. Utilize it means allow you to use it. Because anybody can get the signal, but can you use it or not is another thing. You can receive the signal, you need this receiver, meaning it will allow you to receive it, dissipate it inside your house so you can get it. You can utilize it. Any comments, any questions, guys, about the cable TV or the TV outlets? So we have multiple outlets. Go to a splitter. That's from the other end of the splitter. You can go to a satellite dish. You can go to a cable TV service, or you can go to an antenna. Or you can go to all of them with another splitter. What you can do in a coaxial cable in TV, guys, is you can't tie them all together. You can't get the core of the coaxial cable, tie all the cores together and send them to multiple sources. Okay, any comments, any questions? So everybody understand what the coaxial cable is supposed to do? Bring the signal in, split the signal, take it as a home run to every one of these TV jacks. Okay, the article that talks about the rules and regulation, guys, they have a whole article that talks about it. Article 820 talks about coaxial cable. A couple of things to understand is coaxial cable must be grounded. This is how they do it. At the demarcation point, grounded as close to the point. So here's my house here. Here's my coaxial cable coming from my antenna or cable TV or whatever. This is my signal. Here's my splitter. I split it right here to 4, right? And then I don't have colors here. Then and here's my shield. Can you guys see the shield? Right here, guys, you are to ground the shield. This point, right, as it enters, as the coaxial cable enters the house, this point right here is called demarcation point. The demarcation point by code is the point where the coaxial cable or the phone cable enter the house or the building, the demarcation point. The code requires you to ground the shield of that cable right at that point. So you either drive a ground rod or they have something called inter-system bonding jumper that you ground to. So the shield of the cable must be grounded before it enters the house. So that's how you ground it. So that's the grounded part of it, required by the code. Then do not run the coaxial cable in the same raceway or boxes or cables with lights and power. This is coming, guys, with all low voltage systems, security system, phone, data. We cannot, shall not, will not put them in the same box or the same cable unless they're listed for, or the same conduits as we distribute these signals through the building. So that when you go, Matt, when you start designing building, you're going to see that there will be conduits dedicated to fire alarm system and conduits dedicated to the power and lighting. And sometimes even we have conduits dedicated to fire alarm by itself. We don't want to mix the fire alarm with the security system. Any comments, any questions, guys, about that cable TV? The same thing that I'm talking about the cable TV here almost applies to, or the TV applies to any other low voltage system. Same thing from Article 830, guys. Separation. As you put them in, the coaxial cable must be separated 2 inches. So here's what we do. Who am I going to pick up? Adam. When you drill your holes, here's one hole, here's one hole. In this hole, I'm bringing here 14-2 cable. In this hole here, I'm bringing coaxial cable. So that's separation of 2 inches. 2 inches. So that's why when you drill your holes through studs, coaxial cable and phone and data will be in a different hole than the power. Does that make sense? That's coming from this article, separation from power and light, 2 inches, as you drill your holes when you place them. If you're doing them underground, guys, if you have a trench, here's my trench. Here's my power cables coming in here. And then I have to separate them 12 inches, and then I put my coaxial cable at the top. Does that make sense? You have to put, if you put them in the ground in a trench, you have to trench them and have a 12 inches. Later on, guys, not this yet, next week, when we start laying out the site, and you have a trench bringing the power to the building, you're going to take into consideration, if you are to use the same trench for power and low voltage, which is okay, you have to put your power at the bottom, right? And then right at the top, 12 inches, go further 12 inches and put your low voltage cables above it. But you have to separate them 12 inches. Everybody knows why the separation. 2 reasons for separation. Safety, because you don't want the low voltage to be messing around with high voltage, right, as they work on their equipment. Safety factor. And number 2 is also interference. You do not want the 120 signal 60 hertz, 120 signal 60 hertz impose. If you put it too close to it, it might impose a signal into the coaxial cable. Who cares? When you're watching your favorite TV show, it will be disturbed. The signal will be disturbed, so you get pissed off. Don't you get pissed off when the screen freezes, when you're watching your sport, or when you lose the signal? So that's what you want to avoid, losing the signal. Because ultimately, which has the upper hand when it comes to low voltage and high voltage? High voltage. Do I care if I put coaxial cable next to my power line? The power line, do you think the power line cares? No. The one that's going to be affected is the lower voltage, because these very micro currents going through them. This is have amps going through them. These are micro amps going through them. So it's going to impose signal. It's going to screw it up, basically. The power will screw up the low voltage. Any comments, any questions, guys, about that? Does it make sense? Yes, no? So that's your a couple of rules. So that's basically it in terms of separation, complete separation from power lines. Complete separation. Satellite antenna, one of the sources of the coaxial cable to get you a TV is called satellite antenna. It's called the dish. You guys are very familiar with it, with the dish. These guys, what they do is they collect, the antenna will collect the signal, get them from the satellites that's orbiting the Earth in the Clark's belt here, orbiting the Earth to receive the signal, and send the signal down into the receiver so you can enjoy these shows. We'll look at the signal in a second here. Be installed an antenna, check with the local authorities. There's a lot of regulations, guys, when you put an antenna, based on where you live. So there's regulations you have to be aware of. You have to be far away from the power lines and so forth. So that's your antenna. Here's how this boy works, guys. You take a signal, you beam that signal right into the satellites. The satellites empower it and bring it back down into your receiver. From your receiver, you take your coaxial cable and you bring it into a splitter and into a receiver here, satellite receiver, and from here you can put it in your big plasma TV. And the signals here are beamed through modulation, demodulation, and they send it back. They empower it, high frequency signal shot all the way to satellites. The nice thing about this one, I can receive, by doing it through the satellites, guys, you can receive a signal from China and send it to the other end of the Earth. So before that, it used to be, if you have towers, the towers, that's why they have these telecommunication towers so high, because they need to see each other within, right? So it needs to be able to see each other to communicate with each other, the tower. But for when we got smart enough and we have satellite dishes and we have satellite orbiting the Earth, you can send to the satellite up, and from the other end you send it to China from here. So it's really cool. The concept of telecommunication is unparalleled. That's how we can beam signals all over the world, and you can use this signal to do anything. Direct a rocket, or you can use it to watch your favorite show that's coming beamed from Australia. So anyway, bottom line for us, what we need to do for us is grab the coaxial cable, bring it to a receiver or splitter. If you want to have another antenna here, you can bring it to a splitter. So you have an antenna as well as a cable TV. You split, bring it to a splitter, and from here you go into your receiver, and you receive your signal. And there's a mixer where you guys can receive from an antenna if you want to, or receive from the satellite dish. Typically, if you have a satellite dish, all your local channels will be beamed on the satellite dish, so you really don't need an antenna. Why do we have an antenna? The antenna, you have it to get your local channels free. So if you have a satellite dish or a cable TV, they always give you your local channels. They collect them themselves and beam them. Okay, so that's your satellite dish. Any comments, any questions, guys, about that? Comments, any questions? One source of getting the signal is a satellite dish. An antenna is another one, and a cable TV, cable to your neighborhood is a third one. Okay, rules for installing antennas and lead-in wires. Lead-in wires are the wires that are coming from the antenna, guys, or the satellite dish into your building. You can also, home television, we move into FM and digital rather than US. All these, if you have a television, radio and frequency, AM and FM, typically a signal, an antenna right at the top of your radio is capable of receiving the AM or AFM. If you're in an area that's high, sometimes you have an antenna just to receive certain signals. Same thing for TV. If you don't have a cable TV or satellite dish, you have to have an antenna to be able to receive these digitally now transmitted signals. Inter-system bonding jumper, I'll talk about this one. This is where you ground the cable as it covers in. And article, radio and television, guys, this article talks about radio and television. The most important things about these systems is separation from power and light. Separation from power and light. Really the most important things. Here's a couple of things, guys, from the article 810. Antennas and lead-in wires must be securely supported. So you can't hang a cable TV right on your tower hanging around. You have to securely support it. Makes sense, right? Not attached to the service mass. Power. Have you guys seen in dwellings where you bring the coaxial cable and they attach it to that pipe that's coming to the meter? That's violation of the code. You cannot attach a coaxial cable or a phone cable to that what the so-called service mast. That's that pipe that's bringing the power to your house. Separation. You have to move them away. Not attached to the poles that carries light and power. Light and power wires over 250 volts. Over 250 volts. So separation. Though utilities use the same power lines, guys, for coaxial cable, they have to separate them. There's rules for separation in them, though. And the lead-in wires that coming down, they have to be securely attached to the antenna and securely supported. Securely attached and securely supported. It makes sense. If you have an antenna, guys, can you have the wire just hanging in there? Do you want it to, you know what, if you have a wire and the wind is playing with that wire, you know what's going to happen to that coaxial cable? Get loose. When the coaxial cable get loose, what's going to happen to the signal? You lost the signal. So all these are common sense. Same thing, antennas, wires, coaxial cables, all these have to be, keep them away from the power and light. You can't imagine how much they emphasize separation of the coaxial cable and the phone cable from the power and light. Two reasons, safety and interference. Safety for the low voltage guys when they're working on it, and interference because you don't want to corrupt the signal in it. Should not cross over. So the same thing, the outdoor antennas and the lead conductors that's coming in, guys, should not cross over light and power. You don't want to cross over light, safety, and power lines. Shall be kept 24 inches away from from open light and power conductors. So if they're on a pole or open wires, you have to separate them 24 inches. You can put them right next to it. Shall not be run under open and light power conductors. Antenna conductors shall not be run under the open light and power conductor, under the open light and power conductors. So there's a few rules if you're going to go aerial with the coaxial cables that you have to follow. Any comments, guys? Any questions without getting into the details? So if anybody's asking you to design a coaxial cable between multiple buildings on a pole, you better go in and review a couple of articles in chapter 8. Chapter 8. A couple of articles in chapter 8 for the clearances and so forth. Okay, any comments, guys, about the cable TV? Summarize. Cable TV, coaxial cable must be completely separated from the power and light. We talked about this one. Not terminated in any box with power and light unless you separate them. Must be grounded as you enter the building, right? Must be supported to the dish as well as supported as it enters the building. Must be grounded at the demarcation point. Any comments, guys, before I move into the telephone wiring? Any comments, any questions? So for our project, guys, you're going to bring a coaxial cable to the building with a splitter, 1 in, 4 out, and go to every apartment. In the apartment, you're going to have another splitter, 1 in, 4 out, and go to 4 locations in the apartment. And then you have then you can have your receiver at any of these 4 locations. And then you can receive as many signals as you want. Okay, telephone wiring. Telephone is Article 800. You guys talk about telephone wiring. I don't know if none of us probably were around when they did the deregulation of the phone industry, meaning is some people will own the cables, but anyone can jump in. That's why they keep changing your phone carrier from one to another. The phone lines that we have right now are like highways. Like interstate highways, think of them. Anybody can use an interstate highway or any highway, right? Any one of us can use a highway. Same thing, guys, for the phone lines. They're highways for signals. Anybody who has the money and the technology can buy time and use these highways. That's why they keep switching you from one company to another and so forth. There are people, though, who own these highways and maintain them, which is the telecommunication. That's your deregulation is. Anybody can use open market. Anybody can use these highways to transmit signals and come to the customers and recruit them. Okay, because of this one, a lot of people's phones are done by do-it-yourself and so forth. But like I said, Article 800 talks about it. The most important thing is about the phone begins called the demarcation point. The same thing. Here's my phone line, guys, coming in. Here's my phone. At the point where it enters my building, right at this point is called demarcation point. Can you guys see that? So the utility will cable you, bring you a phone line up inside your building to a point. This point is called demarcation point. The NEC code book in 2008, guys, start requiring you, here's my house, it's sitting like this, to have an outlet cable to the demarcation point. So from here in, this is the responsibility of the phone company. This is phone company. From here, this area here is your responsibility. In terms of, so they bring the wire into a splitter, typically in your basement or your garage. They land that 22 gauge, 4 pair, 22 gauge right into that splitter. And that's what the telecommunication company stops right there. You will cable into that little splitter there as many outlets as you wish. Any comments, any question, guys? I want to emphasize the word demarcation point. Demarcation point is the point where the phone line or the cable TV, the same thing, guys, they call it demarcation point, enters the building. Why it's so important? That's the point where who's responsible for what. From the demarcation point up to the utility, that's their responsibility. From the demarcation into your building, that's your responsibility, number one. Number two, you also ground right here. You are to ground the shield, if any, that comes with the phone line. The same thing with a coaxial cable. You are to ground right at the demarcation point. Any comments, guys, about the demarcation point for phone as well as cable TV? Same point. They call it demarcation point. You ground. Typically, if you're coming from underground, guys, your phone lines will have a guide wire. You have to ground it. Phone lines typically don't have a shield. They're twisted, but they're not shielded. So if it's not shielded, then you don't have to ground it. Any comments, any questions about that wire? So that's my phone, exactly like the TV. In 2008, guys, the NEC code book requires you at least one phone outlet cabled to that demarcation point. That's all what the code talks when it comes to phone. One outlet. Where do you want this outlet? Anywhere you want it. Kitchen, living room, bedroom. Now in our project, guys, what did I say? Adam, I said I think I need one outlet in every bedroom and living room, right? One phone outlet, every bedroom and living room. But the code requires only one. Again, here's the telephone wire. Do you see, guys, how we're repeating ourselves now? Telephone wire is not to run with in the same raceway with electrical wiring system. That's it. So as you drill a hole in the stud for your phone line and cable TV, that hole have to be a separate hole than your power lines, your power conductors. Same thing, the phone lines, guys, cannot be the same outlet and junction boxes with power and lighting electrical wiring. Can I, guys, get you to understand phone lines complete separation in terms of running them in conduits and cables, as well in terms of terminating them in boxes from the power and electrical wiring? Any comments, guys? Any questions? Here's your phone line, guys. Typically, you have 2 pair or 4 pair. This is the most 2 pair or 3 pair. You have your green and red. Typically, that's what you have your ring and tip and so forth. There's one line. You have a spare. So in order to get a phone, all what you have to do is just 2 wires. 22, I believe they use 22 gauge here. 22 AWG or 24 gauge. I think it's 22 gauge. 2 pair. So that's 22 gauge wires. All what you have to do is just 2 wires. They send the signal on one of them. And another one could be for spare. You can have a 3 pair. They come in pairs, twisted pairs. So that's how you wire them. When you wire them, there's 2 ways of wiring them. There's a daisy chain. Can you guys see how they're daisy chained this way and they work? Or there's home runs. Home runs is you come from each one of these like this. Oops, this is junction box. No, not like this, and like this, and like this. This is your home runs. And that's what I would like you guys to do for this project. I would like you to bring all your conductors home runs to a splitter, a phone, not TV now, phone splitter, and you land all these cables this way into a splitter, and you go to different locations. You go to different locations. I believe this is better if you're gonna get your internet through the phone too, so you can put your receiver anywhere here or here, and you get your internet as long as you have the receiver or the router. Any comments? Any questions, guys, about a couple of things? Here's a color coding that they use. All what you need is just 2 pairs to get you a phone. Another 2 pair will give you another line. And I hate to say that in the digital world, guys, right now, because you can get digitally, you can get multiple lines on in a 2 pair. I mean, with Cat5, you can get many lines on Cat5. As this, if you have a Cat5 cable TV, you can have your internet, you can have multiple lines on it, and you can have your TV on just one Cat5. So it's a, I don't know if you guys lately, it has been a mixture between internet, between a whole mesh, internet, phone, and TV. All these signaling, they call them signals, either audio, video signals, or data signals. All of them are becoming almost irrelevant. You can any means can get you any one of these signals. Coaxial cable. I can get a coaxial cable. I can receive my audio, video signal. I can receive radios on it. I can receive TV on it, right? Audio, video for TV and radio. As well, I can receive a phone through the coaxial cable internet, and I can receive my signal, right? That's you get the high-speed coaxial cable coming to you. And also, of course, now there's fiber optics. Fiber optics, they're becoming all these means, guys, between twisted pair, coaxial cable, fiber optics, all of them, think of them as interstates, highways. And you can send in an interstate like 494. You can have trucks driving down 494. You can have motorcycles, and you can have Chad's Suzuki driving down there, or you can have anything you want, right? Think of all these means are highways, and all these signals. You can drive in this highway any signal that you wish. Connect it. Thumbs up, Chad, that we fully understand that this is how the communication is now. You're having a highway. The highway can be two twisted pair. The only difference is that now you're talking about alleys, how far you can go through alleys, right? Then you widen it a little bit. Now you have coaxial cable. Now you're talking about state highways. Now you widen them a little bit, and you're talking about interstates, free highways, and now you're talking about fiber optics, right? What's the difference is more signals, faster. That's how the telecommunication industry is. More signals, faster. Any comments, guys? Any questions? And when I say signals, I mean phone data or internet. Okay, the last thing, guys, we talk about. So we got the phone, we got the data. For the phone, I would like you guys to do the following. Please be aware of that one. You're going to bring the phone line here. You're going to split 1, 2, 3, 4. Each one is going to come to every apartment, and then you split 1, 2, 3, 4. So this will be in every apartment. This will be the common. Does that make sense? And so here's apartment 1, 2, 3, and this will be 4. So there will be 4 of these. So you bring 8 pairs, or typically 8 pairs coming into the apartment. That's what we're going to do it. Split it into 4 locations. Each apartment will have 4 twisted pair. I mean, 2 twisted pair coming to every apartment. 2 twisted pair coming to every apartment. And all this is achieved by these splitters, connectors that you do them typically in the laundry room. So you guys will be drawing this one for me. It's gonna look exactly. That's like a TV, right? Isn't that what we did with TV? Splitter, split it into 4 inside the apartment, split 4 again, or more if you want to. So that's what you guys are gonna be doing for your friend Chad. Okay, signaling circuits. Signaling circuit, these are a fancy name, guys, for a security system. And they define a signaling circuit, an electrical circuit that energizes signaling equipment, buzzers, chimes. Okay, signaling equipment include a chime. That's your signaling equipment. Doorbells, buzzers, or code calling systems, or signaling lights, or whatever. Dedicated lamp. Okay, so there's hearing impaired people. What do you do if you need to have a doorbell for somebody who can't hear? Have you guys thought about that? American with Disability Act. It's the law. When you design a public building, you have to take into consideration the American with Disability Act. That's a law, the state law. We adopted the American with Disability Act, so you have to design it so impaired people, blind people can you have to give them other options of wording. So if somebody cannot hear, what do you need to do? You give them something that you can see. Somebody cannot see, you can give them something so alternatives. You're going to give them the ability to see or hear, and sometimes touch. You know what I mean? Typically hear and see. So if they can't hear, what do you need to do when you have a doorbell? Have a doorbell with a light, that the light goes on. So hopefully they will look and they'll see that there's a light, and this means there's somebody knocking at the door. So these are the options that to keep into consideration as you design buildings. Now for dwellings, only if you are designing a house and you know somebody is going to be living in it who cannot hear, right, deaf, then you design this way. But if it's a public building, you have to take all these into consideration as part of the American with Disability Act. And that takes into a lot of other things. The height, guys, for disabled people, the height of the receptacles, the height of the switches, and a bunch of other things. Okay, so you can have a signal like this. Let me share with you a couple of other pictures, and then so As these are all the boxes that you can use, guys, to terminate phone and data. Derek, my friend, since phone and data are fire-free systems, they do not, from a fire shock hazard and fire hazard are no shock, no fire hazard with these. Then when you guys terminate them, you can terminate them into no box. You cover like this one, you can terminate them right into this one. You don't need a box. Unlike power, why do you think we have a box every time we terminate a switch or receptacle? Two reasons. Number one, shock hazard, because you don't want people, if they are to be around the electrical, to shock themselves. And fire hazard. If there is an arc and spark, you want the arc and spark to be contained in the box. Now for phone and data and signals, there is no arc and spark. There is no fire initiated from these devices. So they're shock free and fire free. So you can, all what you need is just a termination cover like this to get them. So just be aware of that one. Here's how this is what I would like you guys to do for your cable TV. That's exactly how it looks like. Home runs from every TV outlet into an amplifier or a splitter. Amplifier if you have a cable. Then if you have an antenna, or if you have Cat5 or satellites, which is the most common now, you need an amplifier. So you can either land them on an amplifier and amplify these signals and distribute the signals through your building. If you need to take it to multiple locations, you have here a splitter. You can have a splitter that you can split the signal and go to multiple locations, to multiple amplifiers. Any comments, any questions? Any comments, any questions? That's what you guys are going to be designing for your friend Chad. We talked about the splitter. It's going to look like this. 1 input, 3 outputs. You can have 2 outputs and 4 inputs. Two inputs and 4 outputs. Here's your antenna. You have to physically, mechanically attach it to the building. So it cannot be, there's rules and regulations about attaching it far away from power lines. Antennas, dishes. If you are to put an outlet and a phone in the same box, which you can you guys see that? Can I have one box which houses my 120 receptacle as well as my low voltages, as long as the box has separation? Can you guys see that separation? Everybody can see the separation? You can have the same box as long as you have separation between them. Or you can have a cover that covers them, one in a box, one not in a box, but as long as they're separated, that's what you need. Okay, when you bring your coaxial cable, guys, this is called inter-system bonding jumper. Inter-system bonding jumper. Inter-system bonding jumper, you have, as your coaxial cable comes into the building, I'm going to show my coaxial cable coming in here, and terminated to the building, you have to bring that number, I think number 14 they use, number 14, and the shield, can you guys see that? The shield of the coaxial cable must come into this terminal. This is called inter-system bonding jumper, required by code, right by the meter equipment, or the main service equipment. It has a space where you can bond the shield. Can you guys see that? And then you can take number 6. This will go, number 6 goes all the way to a ground rod or to the grounding electrode system of your building. Can I get you guys to understand this is a requirement for phone and TV for every building? Right by the service, the electrical contractor must install that so-called inter-system bonding jumper for the low voltage disciplines, all the low voltage disciplines, to ground their shield of their cables right into it. So if I have a phone, here's my phone line here. If I have TV, and here's my shielded cable to the TV, you take the shield and you ground it right here. Do you guys see that? This is a point where you ground the shield of all the low voltage systems. Can I have thumbs up, Chad? We fully understand that. It's called inter-system bonding jumper. Required to be by the service, by the meter, wherever your service is located. You have to bond it to the grounding electrode system of your building. So that's talking Talked about the satellite, receiving signal. Here's how satellites works, guys. A couple of splitters where you can get a couple of nice. Okay, here we go. So here's my receiver. I can have connect to a proper terminal on the satellite antenna. You can get your satellite antenna. You can get your cable, and you can get your standard antenna here. They all come, can you guys see that? They all come into a receiver. You have a selection switch that can take you from cable into antenna, standard antenna, bring him to the receiver, and from the receiver, now you can receive a signal from a standard antenna, a cable TV, or a satellite dish. Anybody has that? You know, a lot of people have either an antenna or satellite dish or cable TV. Most of the time, guys, especially in dwellings, if you have a cable TV, you get all your local channels through that cable TV, so you don't have to worry about standard antenna to get them. If you have a satellite dish, the same thing, guys. Whatever package that you go with, they'll give you your local channels, so you don't have to worry about that, having an antenna. The whole idea, guys, is to try to avoid having that stinking standard antenna on the roof. You know, that's why you have that satellite dish sitting in there or cable TV coming to your house. But this is a system where you can mix all of them together. So that's my mixer. Here's how it looks like, guys. Satellite receiver, satellite N, and TV, and the phone. Then, of course, there's also with the satellite, you have a phone jack where you can order things and through phone and so forth. When you have your dish, if it's outside, there's rules and regulations how deep you guys can go. 4 feet minimum, plus 6 inches minimum below frost line right here. So this is how deep you have to go when you build your 4 feet. Allow posts to drain. Look at the gravel as you build the foundation for your satellite dishes. This is, I mean, be just aware of that one so it doesn't tip. So here's how you ground the shield. At the demarcation point, any shield that comes with any telecommunication cable must be grounded. That's your number, I believe, number 14. That goes to right in here. This is my demarcation point. And you bring coaxial cable to set of cable boxes, coaxial cable to satellite dishes, so you can come right in here and ground it to the inter-system bonding terminal. Or bonding jumper, inter-system bonding terminal. Can you guys see that? How you have to take the shield and ground the shield. You have to ground the shield. For cable TV or phone lines if they have a shield, or phone lines if you have a shield. I don't know if you can see that, but owners, so you can see there's a box that sometimes they give you line of demarcation. I don't know if you guys can see that line of demarcation here for the low voltage. And one side is for the utilities, another side is for you. And I believe this, I don't know if you can see, this is the green line. I believe that's where you're grounding. You take your grounding, bonding conductor. No, the blue, it looks like that gray conductor is my bonding conductor to inter-system bonding jumper. Looks like they're using, I don't know why they're using that gray here. So anyway, so that's the wire that you shield your, you tie your shield to it. We talked about the phone jacks, guys. Here's how you can bring them to a gearbox, or you can daisy chain them. Two options for phones. Wiring methods, typically 2 pair. They'll give you 2 lines. Again, I mean, these are the old ways of doing it. Different type of systems, guys, that you can do. These are the buzzers. I'm going to move through these are the chimes. I'm going to move directly into wiring for the chime. Rough-in box for flush-mounted chime. This is how to flush for your chime. Here's how your chime looks like. You can either plug them in, or here's the wiring method for a chime, guys. This is really interesting. So you can have your chime is sitting right in here. Can you guys see that? And then you need to go a 3-wire cable going all the way to the front. If you have a front and back, you need 15 amp circuit, right circuit breaker here, to a transformer. Can you guys see the transformer? Then you have 16, typically 16 2 AWG cable coming in here, and two wires, the same thing, 16 2 to the rear and the front. And you can have an extension chime. You can have another chime if you want to in two different locations. Can you just see that? How they wire them? You can have one chime, and you can have a 16 2 wire going to the rear, to the front, and you have to power them with typically 24 or less, 24 volt or less, 16 volts is typical for these systems. Any comments, any questions? These are called class 2 circuits. Class 2 circuits. This, everything here wired with 16 volts is a class 2 circuits. They are free of shock and hazards. Shock hazard as well as fire hazard. Any comments, any questions, guys, about the chime? So when you guys yesterday, when I told you you have to have a push button in the front and the back and a chime, be aware that this chime has to be powered. So you have to go assign a power to the chime. How do you assign a power to the chime? Well, what I want you guys to do here is go home runs and say panel -1 circuit number 1. So grab a lighting circuit mat in the area, because you're talking about 10 watts on these babies. Not a whole lot. 10 watts, 15 watts. You're not talking about a huge amount of power. So throw them on any lighting circuit in the area. Any lighting circuit in the area. Cool? So what we do from the panel, typically you come from the panel, from that whatever circuit here, you go to the circuit, you tap that circuit into the switch. It is your transformer here, and that's where you go with the class 2 circuit. So that's your chime. This is how you tie the front and the back, guys. Look at the transformer, very typical. I don't know if you can see that. They come from here, and you tie it to a transformer, nibbled to the panel, and then you go to the and you take a cable from the rear and the front, and they all meet directly at the front, at the chime. A couple of watts. Look at the watts, guys, for them. Chime and clock. Maximum, you're looking at 15 watts. So not a whole lot of juice in them. Any comments, guys? Any questions? Any comments? Any questions? So I hope that chapter, guys, will help you go through the low voltage. Please read it. You guys are designers. You will be required to do low voltage at one time. A lot of companies have, like Michelle, you guys have, don't you have a group, the low voltage? Yeah. A group low voltage. You could be that member of the group, the low voltage. They go to the next level. Right now, we don't know where you guys are going to go. You could be designers, low voltage, high voltage, whatever. So you could, but this information will give you multiple tools to be a well-rounded electrical designers. Let's take 5 minutes, and then we're going to go to the fire alarm system. Thank you.